Duh.
We're going to find a little bit more about vectors, being able to find the components of a vector by subtracting the coordinates of the initial point from the coordinates of the terminal point on the vector. One of the things we need to do with vectors is break them into their components, because by breaking vectors into their horizontal and vertical components, we can then combine vectors. And you can see some of the four main forces on an aircraft here. Here's an example of a series of vectors that show the stresses on the different joints in the body under exercise. You need to be able to find the horizontal and vertical components of those vectors to be able to add and subtract them. And all vectors can be broken down into their components. Here's an example from physicsclassroom.com that shows pulling on a leash. And if you pull on a leash, you could actually break that up into a horizontal component and a vertical component. And that's useful for analyzing or breaking down the vector and combining with other vectors. So if we know that finding the components of a vector is important in helping do vector operations, how do we find them? If we have the two endpoints of the vector, the beginning and the end, then we can find the horizontal and vertical components in two-dimensional space if we find the difference in the y-coordinates and the difference in the x-coordinates. And as it turns out, the difference in the y-coordinates is going to be equal to the vertical part of the vector. So in this case, it'd be y2 minus 1, 1. It'd be 3 minus 1, which is 2. So the vertical component of this vector u is equal to 2. Similarly, the horizontal component is x2 minus x1, so it would be 8 minus 2, which is 6. So the horizontal component of vector u, which we call u of x, is equal to 6. So if we know the endpoints, we can find the horizontal and vertical components of a vector in two-dimensional space by finding the difference between the y-coordinates for the vertical and the difference between the x-coordinates for the horizontal. And both the vertical and horizontal components are themselves vectors. We call this one u sub x, the horizontal component vector, and the vertical vector u sub y. This is going to be very useful in the next section when we start adding and subtracting vectors, trying to combine them. We're going to combine their horizontal and vertical parts later. If our vector is nicely drawn to scale, we can also use what's called the parallelogram method to find the components. And if I have this vector u, and I draw a parallelogram with u as the diagonal of the parallelogram, and I complete a four-sided parallelogram, I can then find the two components, because the two components, the horizontal and the vertical, will appear as sides of this parallelogram. So to be able to find the components, if we don't know the coordinates of the endpoints of a vector, we're going to use some trigonometry here. And so let's just look at a vector u anywhere in the 2D plane where it is a certain magnitude that we know, and remember those double bars denote magnitude, at an angle alpha. Well, if we go back to trigonometry, we know that if this is the angle alpha, and it's a right triangle we have here, that uy, the vertical component, is the opposite side, and ux, the horizontal component, is the adjacent side of angle alpha. So if we know that, then we know that opposite over a hypotenuse, uy over the magnitude of u, is going to give us the sine of alpha. In a similar way, we know that since u of x is the adjacent side, adjacent over hypotenuse, u of x over the magnitude of u, is going to give us the cosine of alpha. So we don't know u of y and u of x, so what we're going to do is multiply both sides in each equation by the magnitude of u to get u of x or u of y by themselves. And when we do that, we come up with what are the formulas for the horizontal and vertical components of any vector where we know the magnitude and the direction already. And that's actually more common than the previous example that we used. So the vertical component, u of y, is equal to the magnitude of u times the sine of alpha. the horizontal component u of x is equal to the magnitude of u times the cosine of alpha. And that assumes that alpha is being measured in our standard mathematical way as a rotation in a counterclockwise direction from the positive x-axis. So let's look at an example of this. Let's say we had a vector u that had a magnitude of 5 and a direction of 30.964 degrees, measured from the positive x-axis, rotated counterclockwise. We know that u of y is equal to the magnitude of u times the sine of alpha. So that would be 5 times the sine of 30.964, or approximately 3.0. The magnitude of the vertical component is 3. And in a similar way, we're going to find the horizontal component by multiplying 5, the magnitude of u, times the cosine of the angle, 30.964. And when we do that, we get a horizontal component of 4.0. So the horizontal component's magnitude is 4, the vertical component's magnitude is 3. So you may be wondering, what we found really is the magnitude of those component vectors, 3 and 4 respectively. How do we actually write them as vectors, these components? And how do we account for their direction? And that's a very good question. We create these things called unit vectors, and they're normally called I and j, but in some systems they have different names. But I is a horizontal vector of unit 1. J is a vertical vector of unit 1 also. They're called unit vectors. So we can actually write the horizontal vector, the horizontal component vector, as magnitude 4 at 0 degrees, or more concisely using the unit vector, we would write it as 4i. In a similar way, the vertical vector of uy, the vertical component vector, could be written as magnitude 3 at direction of 90 degrees, or we can write it as 4 times the unit vector of j. So the horizontal component would be 4i, and the vertical component would be 4j. And together, they make up vector u. So vector u can be more concisely written as the sum of its two horizontal and vertical component vectors written using those unit vectors of I and j. So u is equal to 4 times I, 4 times the unit vector in the horizontal direction, plus 3 times j, the unit vector in the vertical direction. So we've learned about how to break a vector into its component parts in the 2D space. That's the vertical and the horizontal components. And we've done that by subtraction when we know the points, and using trigonometry when we just know the magnitude and the direction of the parent vector.